Hi there, welcome back to General Chemistry 1. I'm Dr. Fang Xu, and today in this video, we're going to talk about molarity and dilution. The first concept is concentration. If I have a bowl of salt and dissolve that in water, and then I have two bowls of salt and dissolve that in the same cup of water, which one is saltier? Obviously, the left cup is less salty, while the right cup of water is saltier. If I have two bowls of salt, but I double the amount of water in the cup, if I ask you to compare which cup of the water is saltier, because of the expansion of the volume of water, the most right cup of water is less salty than the middle one. Okay, and actually, it should have the same level of salty taste from the very left cup of water. So how salty the water tastes reflects the concentration of sodium chloride in the water solution. Concentration means the amount of solute dissolved in a given quantity of solution or of solvent. So sometimes we can have mass concentration. That means mass of the solute divides the volume solution. Sometimes we have volume concentration that refers to the volume of solute divides the volume of solution. For example, in Medicare, we have 0.9% sodium chloride solution. That's the normal saline solution in medicine. That 0.9% is a mass percent. In chemistry, we don't use mass concentration or volume concentration very often. Instead, we use the unit of molarity, a concept of molarity. So molarity is defined as moles of solute divides liters of solution. It can be expressed as an uppercase M or mole per liter. So please make sure that for molarity, in the bottom is always solution in the units of liter, not in any other units. If you look at this equation, we have moles of solute. When we have moles, you should be remembering the equation of mass equals to mole times molar mass. And when we have this moles, also we can relate moles to the entities. Number of entities of our species equals to the number of moles times Avogadro's number. Sometimes these three equations can be combined together to solve a molarity problem. For example, here, calculate the molarity of a solution that contains 175 milligrams of sodium nitrate in a total volume of 15.0 milliliter. Well, it asks to calculate the molarity. According to this equation, we need to know the moles of solute and liters of solution. The moles of solute is not straightforward, but it gives us the mass of solute. So we can use the mass equals to mole times molar mass to calculate how many moles of solute are there. The bottom of molarity equation requires liters of solution. It already gives us the liter of solution. It's in the milliliter. We just need to do a unit conversion to convert that to liter. So let's solve this problem. First, get the moles of solute. The mass of solute is 175 milligram. But when we use the moles and molar mass, we usually need the unit of mass to be in the gram. So we convert 175 milligrams to 0.175 grams. You can also use the box method to do that, but in order to save space, I did not use that method here. Then, after we get a mass, we can get the moles by using mass divides molar mass. The molar mass of solute, sodium nitrate, you can calculate that as 85 grams per mole. So the mole of solute is 0.175 gram divides 85 grams per mole, and you get 2.059 times 10 to the minus 3 mole. And then we can calculate the molarity. So for liters of solution, again, you can use the box method. 15.0 milliliter equals to 0.0150 liter. Then the molarity, just plug in the numbers to the equation. Molarity equals to 2.059 times 10 to the minus 3. The moles of solute divides the liters of solution. Okay, and then it's 0.137 moles per liter, or you can write 0.137 big upper M. This problem is the direct apply of the molarity equation. All right, once we know the concentration of a solution, we can actually change that. So let's talk about dilution. Dilution typically means you already have a concentrated solution, you add more solvent into the solution to make the volume bigger and concentration less. In experimental chemistry, we can use a volumetric flask to prepare a solution with a designated concentration. So again, if we want to know the designated concentration, we can choose a volumetric flask with specific volume. So now the liters of solution is fixed. With this molarity equation, we can calculate how many moles of solute is needed to prepare the specific molarity of equation. After we calculate the moles of solute, use a mole-molar mass conversion, we can get a mass of solute, and then use a scale to weigh the solid with the solute and prepare the solution using the volumetric flask. So the whole procedure is about dilution. We add more solvent into a solution. On the other side, we can evaporate some of the solvent and make the concentration of the equation higher so we can concentrate the solution. But in either case, the amount of solute does not change. And that gives us a very good equation to calculate dilution-related problems. Because the absolute amount of solute remains the same before and after dilution, according to the molarity equals to moles over volume, we can transform this equation to make moles equals to molarity times the volume. It's the same equation. And because the moles of solute remains the same before and after dilution, we can have M1V1 equals to M2V2. The 1 and 2 subscript refers to before and after procedure, before dilution, after dilution, before concentration, or after dilution, after concentration. The V refers to the volume of the solution. Let's take a look at question. A chemist dilutes 60.0 milliliter of 4.50 molarity potassium permanganate to make a 1.25 molarity solution. What is the final volume of diluted solution? Okay, so it's just one procedure dilution, right? So we can write M1V1 equals to M2V2. In this case, we can compare the unit of M1 and M2. So in this case, both of the unit is in molarity. That's great. And also we can compare the units of V1 and V2. So V1 is in the unit of milliliter. V2, it does not say, so we can use any volume, any unit of the volume. And in this case, if we want this equation to be valid, we need to make sure M1 and M2 have the same unit, and V1 and V2 have the same unit. So plug in the numbers. Before dilution is 4.5 molarity times 60 milliliter. After dilution, we have 1.25 molarity and V2, that's the volume we want to get. So solve this equation, we can get V2 equals to 216 milliliters. Okay, let's take a look at another example. A chemical engineer dilutes a stock solution of sulfuric acid by adding 25.0 cubic meter of 7.5 molarity acid to enough water to make 500 cubic meter. What is the concentration of sulfuric acid in the diluted solution in the unit of gram per milliliter? So this question, like before, it's a dilution question. And then whenever you have dilution question, just write out this equation, M1V1 equals to M2V2. And we can plug in numbers. So 7.5 molarity is the M1 before dilution. The corresponding volume is 25 cubic meter. The M2 is the one we want to get, the concentration of the diluted solution. And V2 is the volume after dilution, in this case, 500 cubic meters. I directly apply the two volumes here because they have the same unit and these units can cancel out. Okay, so solve this equation, M2 equals to 0.375 molarity. If you write out the exact unit of molarity, you can say it's 0.375 mole per liter. The unit here, mole per liter, is different from the unit it asks. It wants in gram per milliliter. So we need to do the conversion. With this complicated units, we can always separate them in two different units. One's from the top and one's from the bottom. So one's before the dash, one's after dash. Before dash, we have mole in the molarity. What is asked in the question is gram. So we can do the moles and mass conversion to convert this moles into grams. And we can also do the conversion in the liter to milliliter. So if we do the unit conversion, 0.375 moles, and we want to get the molar mass of sulfuric acid, which is 97 gram per mole. Times 97 gram per mole, we can get the mass of sulfuric acid in 1 liter of the solution. That is 36.75 gram. Now, as I said, this is the amount of sulfuric acid in 1 liter of solution, right? Per liter. So it's in 1 liter of solution. 1 liter of solution equals to 1,000 milliliters. So we can use these two numbers, 36.75 gram, that's the mass of sulfuric acid, divides 1,000 milliliters, the volume of solution, that we can convert the unit to the gram per milliliter. The answer is 0.0368 gram per milliliter. All right, this is the end of the video. See you next time.